Hey friends, welcome back to Engineer My World. This is your home for developing your skills as a doer of science. We are doing Udemy's 100 Days of Python Coding Bootcamp, and we're on day number 2 where we're going to learn data types, numbers, operations, type conversions, f-strings, and we're going to develop 2 apps, simple ones, BMI calculator and a tip calculator. So a lot's changed in my life. First of all, I have a new headset, a new setup. I got a monitor of my own now, a new home, a new job. I go more into it, or I will be on my other channel, my music channel. So if you want to know more about all that personal stuff, check that out. It's in the description below. But what I wanted to talk about for this channel, because that's where we're at right now, is that my last video went super long. So I'm gonna be doing a new format where I optimize my Python reviews, these lessons, and I'm basically gonna give myself more creative license in order to eliminate a lot of the repetition in these exercises and sharings, so that we can really cut out all the excess and just get the most important takeaways, and that way we can save you time and save me time in the production and filming. So yeah, let's get into this. Before we start, if you have the gut feeling that this video is helping you, providing you value, please like the video and subscribe. That pushes the channel out to more people, where more and more people can get access to coding and learning how to code, and we can all learn together and change the world. Okay, that got really optimistic for a second, and I'm just gonna have to chill, even though optimism is good. Let's get to work. Let's start with some basics and build up from there. So let's talk about indexing. So every character in a character string has a numerical representation of where it is within that string, its position. So if you have the string hello and you go to print it, it's going to appear as we would expect in the console. And you notice that H right here is in the first position. E is in the second position, etc. But what if you just want to grab a single letter out of that word? This is where indexing comes into play. You're going to have to index those letters. So Python is a zero index language, which means everything starts with 0. The 0th position is the first position of a series. So if I want to grab the H out of this, it's in the first position of that string, therefore it's the 0th position. So you'd put it in brackets, and it is going to grab the H, and I click run and it shows H. Now that means O is what? The 4th position. So if I change it to a 4, it'll grab the O. Now what if I go like 5? Well, it has no 5th position, so there's going to be an error. Next, we're going to look at concatenation, and we learn that we can concatenate strings of characters even if those character strings are numbers themselves. So first of all, let's do print. Let's take 2 numbers, 123 plus 456. So it's going to calculate that to be 579, right? Well, what if we didn't want it to calculate that? What if we just wanted to combine those as strings into one? Well, we're going to have to put them in quotes then, and we're going to concatenate the character string 123, which it treats like a word, and 456, which is like another word. You click run, and it's going to be those two together, 1, 2, 3, 4, 5, 6. And again, you could put a space there if you want to put them in between each other, and that's how that works. Next is commas. Have you ever had to work with a number that's just so big you couldn't even tell what it was without commas? Like you're like, is it 100 million? Is it 1 billion? I can't tell like readily looking at it. Well, Python has a way of letting us humans see the size of the numbers we're working with, while at the same time not treating it any differently when there's no commas. So we're going to do print 1, 2, 3, 4, 5, 6, 7, 8, 9. We're like, I don't even know what that number is. Well, we're going to compare it to this next print statement where we're going to put in the same number. And this time we're going to put underscores where the commas should go. And now we can see it's 123 million, etc. easily. When we click run, Python's going to treat these two numbers the exact same way. So you can use the underscore to help you out, because after all, we're only human. You know what's actually hilarious? It's actually the next day. I got so exhausted last night with this. I went to my couch, laid down, and actually fell asleep. So I took like an hour nap from 8 to 9 p.m. And funny enough, I woke up and had all these amazing ideas for the site. So I went up to my bedroom, laid in bed, put the laptop like on top of like on my lap, and I just coded for like 3 hours and went to bed at like 1 a.m. But it's the next day and I'm just full of energy. I'm ready to get through this. Let's continue day 2 of this Udemy course. Okay, sometimes you're going to run across functional limitations with some of the functions that you're using. For instance, the len function calculates the length of a string. So this 1000, it's going to be a string because it's in quotes, and we're going to print it. And the answer will be 4 in the console. But if we take out the quotes, it becomes an integer, and the length of an integer is not defined. Therefore, you have this type error. Object of type int, integer, has no len. So I'm going to introduce the type function, which is going to determine or classify what type of data we're working with. The type function is purely analytical. It's going to help us analyze what kind of data we're working with. So let's say we have a num char or character, and it's equal to the string of 1000. To figure out the type of that variable, numchar, whether it's a string or an integer, we're going to use the type function. We'll do type of numchar. And then, of course, we want to print that to the console on the right. So we're going to hit run, and it's going to say that it is a class string. It's classifying it as a string because of the quotes. If we take out the quotes and then run it again, it becomes an integer, and it's going to tell us that. A use case for this is when you're trying to concatenate things into one print statement, because integers cannot be concatenated into strings. So we're going to see this. We're going to ask the user what their name is. So numchar is equal to input of name. I'm just going to say that means what's your name. We're going to run this so I can put in Sam. And then that works apparently, so we're going to print numchar. Try it again, Sam, and it should print Sam. Okay, that's good. Now we want to figure out the length of that, because maybe we want to print a statement saying the length of your name is X. So we're going to use the len function, len input of the name. So it's going to figure out the length of SAM this time. Now it's 3. It's not Sam, it's the length of Sam. Now we're going to try to tell the user what the length of their name is. So we're going to do print the length of your name is, we're going to add in that variable, and then we're going to continue the string characters. We're going to put a space there. So the length of your name should be 3 if I put in Sam, and it should tell you that. We're going to see if it does. Let's spell that right first of all. To restart. Sam. So it calculated the length of it as 3, but there's a type error. It says can only concatenate strings, not integers. So we learned that we cannot concatenate this number into this string. Therefore, this new function that we're introducing is the conversion function from something to a string. So to see this happen, how this happens, we're going to print the type of this character, this variable, I mean. It's still going to have the error, but it's going to tell us what type of input we have here. It's an integer. So now we're going to need to convert numchar to a string. So we're going to use str numchar. So this function will convert everything in here, if it can, to a string. And now we're going to save it as a variable, and we're just going to use the same variable so that it just replaces the previous value, which is an integer, with the new value, which is a string. And then we're going to print the new type. This verifies that the conversion happened. And then we're going to leave the statement alone. It should work now. Run. Sam. Cool, so I put in Sam. This prints the value of 3. Then this prints the classification of it as an integer like we knew already. Then this converts it to a string, and then this prints the type of the string, verifying that it changed to a string. And then this print statement works. The length of your name is 3 characters. I was getting a little bit chilly. I'm trying to save on my electric bill by not running the heater too much. You know, gotta live that bachelor's life. Gotta save that money. So we're gonna start on mathematical operations. This is going to go super quickly. For adding, we're gonna use a plus sign. We're gonna print, let's say 2 plus 3 is 5, right? Right. For subtraction, you're going to use the negative sign or the minus sign. 2 minus 3, that's going to be -1. For multiplication, you're going to use the asterisk, and that's going to be 6. And then for division, you're going to do like you do when you write it on paper, a slash. Oh, and there's one more, exponents. Now you're going to use the double asterisk. 8, 2 to the power of 3 is 8. 2 times 2 times 2. So now we're going to talk about priorities, and I think it's really important in life that we really have priorities. When that comes to math, that is PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. So I'm going to copy over a print statement from my other screen. I'm going to give you 5 seconds to figure out what this answer is going to be. Okay, time's up. The answer is 7. And let's go through this. So parentheses. There are no parentheses besides the print statement, but that's not part of the actual mathematical operation. Exponents, there are no exponents. Multiplication, here's 1. So 3 times 3 is 9, so that's done first. Next is division. We see there's a division here, and 3 divided by 3 is 1. And there's addition right here. So you're taking the 9, adding it to the 1, which is 10, and then the subtraction. So 10 minus 3 is 7. If all things are equal, you go from the left to the right. Like you have 3 plus 3 plus 3 plus 3. You start from the left and go right. So that is my spiel on priorities. Y'all, I just woke up from an hour nap again. Apparently all this talking and teaching just drains me. Like if you didn't know I wasn't an extrovert already, that's your sign. But we're going to get back to work with the BMI calculator. So we're given these 2 input statements asking for a height in meters and our weight in kilograms. And it wants us to get the types of height and weight, whatever those variables are, and then to calculate the BMI by converting the inputs, and then to print the BMI as an integer and then print it again as a float. So let's do that. Let's switch these. I just realized that it's going to be easier to switch them. We're going to do it in different order. So first we know that to get the types, we're going to use the type function. And let's do height first. And yeah, that should be good. But we want to make it like, we want to give the user a nice day. We want to make sure they have a nice day. So we're going to print it for them. And we're going to say height type is, close the quotes, and then you need to add it in. And just like with integers and floating point values, you're not going to be able to concatenate a type function into a string function, into a string. So we're going to have to convert this to a string as well. Run. Height 1.7, weight 86. And it says the height type is class string. So just a quick review, we know that the type of variable the height is a string, which is what we expect because we're using the input function. And then we had to convert that to a string itself in order to display it into the print statement. So we're going to do the same thing for the weight. So I'm just going to copy and paste and then change the wording to weight and to weight. It'll be the exact same thing. So we'll go to the next one. We want to calculate the BMI by converting the inputs to integers. Now, if you convert them to integers, they're going to be like 1, 2, 3, 4, 5. But if you convert them to floats, it's going to include the decimals. So I want to use the float conversion function rather than the integer conversion function in the hopes that it will be more accurate, given that we could enter any height and weight we want. So we're going to do the calculation. So the BMI equation is weight divided by height times itself, or BMI is equal to the weight divided by height squared, right? And for Python, that's going to be 2 asterisks. So I'm going to use the second equation. We're going to try it, and we're going to see that it does not work. And we get a type error. It doesn't work because these are strings. We need to convert them to floats. So the floating point conversion function is float, just like it was for string. Same process. We're going to click run. 1.7, 86. So we're going to see that this doesn't have any errors, so we're good. Now we need to print the BMI so that y'all can see how unhealthy I am, because these are my actual numbers. Now we're gonna print the BMI as a float. Let's prove that these are a floating value first. So let's do print type BMI, and then we know that we can't include floating point values into a string, so we're going to have to separate the print statement into 2 lines of code. So we're going to say your BMI is, and we expect it to be a float value, so we're just going to put that in there. BMI. Yep. Run. 1.7, 86. So it calculates it, and it says it's a class float because of the calculation. And it says your BMI is, the float, I just put that there because we expected that, is 29.757. So now it wants a big boy. Now it wants us to write it as an integer. So we're going to do the same thing. Basically, your BMI is, but we expect it to be an integer this time. And now we're going to convert it to an integer before we print it. Run. Great. Now it cuts out the decimal points as an integer to just 29. And that's your BMI calculator. It is bad to manipulate people, but it is great to manipulate numbers, except if you're the media, of course. Anyway, we won't get into that. We're going to get into number manipulation. Let's start with rounding. So if we want to print 10 divided by 3, 3 goes into 10 3.33333 infinity times, right? But if we want to round it, we can put a comma. Well, no, we have to use a round function. And then put a comma to see how many digits we want to round to. We want to round to 3. It'll be 3.333. What is wrong? Another parenthesis, 333. if we want to round to 5, we just change that to 5. Now, floor division. Floor division is figuring out how many times one number goes into another number through division. So let's use the same example. Well, let's do 9 first of all. We'll do 9 divided by 3. That would print the value of 3, but if we want to know the floor division, we're going to use the double slashes. So 3 goes into 9 3 times. How many times does 3 go into 10? 3 times. It prints 3. How many times does it go into 11? Also 3, so it prints 3 again. How about 12? Well, 4. So the answer is going to be 4, and that is floor division. Now the modulus is the remainder after the floor division is done. The modulus is super important. In my final project for linear algebra, my senior math course, I wrote fast Fourier transform algorithms, and I needed to know what the modulus was and how it could be applied. So this modulus may not seem very important, but depending on what applications you're working on, it can be very important. So it's the remainder of floor division. So let's do print. Let's do 9. And for modulus, we're going to use the parentheses symbol. 3 goes into 9 exactly 3 times. So there's no remainder, right? So the answer should be 0. And it is. 3 goes into 10. Oops, didn't mean to delete that. 3 times, but the remainder is 1. So we'll get a 1. And that is the modulus. Next is the running operations. Now let's say you're watching your favorite baseball team. For me, that's Mariners. Mariners lose a lot. So you're watching your favorite baseball team and they're losing because the score is going up. So everyone starts at score of equal to 0. And then, oops, forgot to print that. Let's print that, you know. We're going to print the score. And score is 0, right? So the other team scores, and you could do score is equal to itself plus 1, right? Because it'll update, it'll take that variable, which is 0, and add 1 to it, updating the variable at the same time. That's one way to do it. So the score that's printed is 1. Or instead, what you could do is put the add sign before the equal sign and then just put the 1, and it's going to do a shorthand of that operation or running operation. And it's also 1. That's pretty cool. The other team scores again. You're going to do plus equals 1, and it's going to be 2 now. And that's a quick way to add up a running value. Alrighty, it's time to do f-strings. And this is something I learned in this course, actually. And it's really cool. So let's say we have the score is equal to 0, as we just did. When we figure out the type of value this variable is, we're going to see that it is an integer because it's a number that is without decimals. And then if we were to say the height is equal to 1.8 and print that type, then we're going to see that because of the 0.8, the decimal, it's a floating point value. Now we're going to introduce a new type of data, which is Boolean data, which is from Boolean algebra, like or and true and false. So we're going to make a variable called isWinning, and we're going to make it true. That is the Boolean logic, and we're going to print that type, and it's going to tell us, it's going to recognize, because it recognizes this true, it's going to recognize it as Boolean data right there. So f-strings really help simplify the representation or the printing of these various data types. If we want to concatenate all this information into a statement in the console, let's do that in the conversion way. So we're going to have to do print we're going to say the score is, and then you have to add in the string of score, right? And then you have to say the height is, then you have to add in the string of the height, right? And then you gotta say is winning, question mark kind of, if you want. And then the string of that variable. And see how like laborsome this is? I might not have even calculated it correctly or typed it in correctly because that was a lot. Oh, I did. Okay, so score is equal to 0, height is equal to 1.8, and is winning true, right? That was a lot of work. If we want to concatenate, if we want to display it without concatenating necessarily and converting, we're going to use f string. The f string is this symbol. It's going to be able to do the hard work for us. So we're going to print the f string score of score is in ellipses. And then we're going to do the height is also in ellipses of that variable. And then is, let's do the same thing, is, I didn't mean to capitalize that, is winning. And then another variable in ellipses. And then the end of the f string. The f string contains everything inside these quotations. And we're going to try printing that. And look, what's a little bit different is no colon there, but still it's the same thing. Score 0, height 1.8, is winning true. So all that information was represented in less code and with less work. So f strings really important if you want to cut down on the work, and it's a nice little trick that you can use in Python. Okay, y'all, we have made it to the final project. They want us to make a tip calculator. So here's the setup. The bill was $150 split between 5 people with a 12% tip. Each person would have to spend $33.60. That's the answer. They want us to format it into 2 decimal places so you don't get that 0.6. You get 60. And this rounding stuff we've went through already. And we are kind of given a liberty to make this app however we want as long as it works. So the guide we're following though is to ask the user for the bill price. So let's do this. Let's do this. We're going to do this first. We're going to name a variable bill, and we're going to ask them, what is the price? What is the bill price, right? We're going to just say this is going to be including tax because we don't want to calculate tax. You don't need to. It's going to include the tax, and this will just quicken like this whole video. What is the bill price? So we know how 150. So that nothing wrong there. And then we're going to ask the user for the tip desired. So we're going to name that tip, and we're going to say what is the desired tip percentage, because that's how tips are done here in America. And then we're going to see if there's a problem with that. No. We're going to say 12, no. And then we're going to ask how many people are splitting the bill. So let's make a variable called people and say how many people. And that should work. I'm just going to give a little output here just to catch up, I guess, with the numbers. Let's do the let's just call that the inputs. So we're going to go print. We're going to print the bill. We're going to print the tip. And then print also the people. So bill, what is the bill price? Let's just be clear, that's a dollar amount. And we're going to be clear this is the percent amount, just in how we phrase the question. We're going to hit run. What is the bill price? 150. What is the desired tip percentage? We're going to say 12. And how many people? 5. So 150, 12, 5. That all works. Now we're going to calculate the entire bill. So this is how we're going to get into some math. So if you times the number by itself, you're getting 100% of that number. So 100% of 5 is 5 itself. But 109% is 9% more than that 100%. So if you want to do the percent 12%, you're going to have to multiply the 150 by 12% and then add it onto itself. In other words, you're going to times 150 by 1.12. So we're going to calculate the bill price, the total, which again is the taxes built into the bill price. And total is going to be, now we're going to have to convert this to a float for the reasons we talked about before. Float of the bill plus 1 plus the float of the tip. And then we're going to have to divide the tip by 100 to convert it from a percentage to a decimal. So we're going to take the percentage of 12, divide it by 100 to make it 0.12, and then add that into 1. And then multiply that by the bill price. Yeah? And then we want to take that total and divide it by how many people there are. So we're going to call it the share price. It's going to be equal to the total, which should already be a float, so we don't have to do it. We don't any conversions. And then we're going to make people an integer because you can't have half a person. And that's the two main calculations we need. Now we're going to round the final values to 2 digits. So we're just going to, looks like we're going to update the variable total is equal to the rounding of itself to 2. And share is equal to the rounding of itself to 2. Let's just make sure that we're on the right track. So let's call this outputs. We're going to print the total and we're going to print the share to make sure all the math's working correctly. 150, like we did before. Come on, 150. Desired tip percentage, 12. And how many people? 5. 112.5. It says the final bill is 168. And the share price is 33.6. And that's the price that it gives us, the 33.6. So we know everything worked well, correctly. We've rounded appropriately to 2 decimals. And next, it wants us to actually format it to 2 decimals. For instance, if it was 168.50, it would do 0.5, but it's dollars, so we kind of want it to show 50 cents, or for a better example, 33.60, not 33.6. So this is something I had to look up. You're going to update the total variable again into this little nifty operation to f, and that f is representative of the total being a floating point value. It's a format specifier, and you're going to do dot format total. So you're saying you're going to format the total to specify 2 decimals of that floating point value and save it as the total variable, writing the previous totals value. We're going to do that the same thing for the share price. Forgot the period there. Now, regardless of what it computes, it should always do 2 decimals. Now it's time to display the answer, and we're going to use f strings because that's something we just learned. So the print, we're going to say the f string, the price for a number sign bill in ellipses with a ellipses tip percent is $, total, that variable, total. Therefore, the price per person is $. Oh, let's put in the number of people there is in here. Therefore, the price for all people, how many people there are, people, is the price of the share price, the $sign of the share price. And yeah, hopefully that works. What is the bill? 150. What is the desired tip percentage? 12. And how many people? 5. All right, everything looks good all the way until the end. The price, and we're going to see if it and works. So the price for $150 bill, yeah. For $150 bill with a 12%, I was just so in a hurry, tip. We're going to put in the tip here. The price for a $150 bill with a 12% tip is $168.00. That double O is because we formatted with that format specifier. Total dollars, right? Therefore, the price for all 5 people is $33.60, and we did it. We have our tip calculator, fam. We made it all the way to the end. Thank you for joining me for this Python lesson. I hope I was able to communicate everything that I learned effectively so that you could take away a lot of learning. Feel free to watch the video again if you want to put everything more concrete into your memory. And I included the link to the course in the description if you want to take the Python course for yourself. So just wanted to say thanks for joining. If you got value out of this presentation, subscribe to my channel so that you could see day 3 when I finish it, and like this video to push it out to more people. So have a great day, and I'll see you next time. Don't hate me 'cause I'm beautiful. Don't hate me 'cause I'm beautiful. My name is Harry. I'm so very... Oh, I'm recording? Oh gosh. Oh god. Actually, you know what? I have one more thing to say about priorities because I just realized that I misspelled that word, and that just really goes to show you that we're prioritizing coding and math here. We're not prioritizing spelling. So, good life lesson. Focus on what's important and don't get too butthurt about it. My dad's not going to like that I said that.